Welcome to the video lecture series of Grade 10 Physics. Today we will discuss about the lesson electricity, and I'm going to explain the difference between electric potential and potential difference. So for the better understanding of this concept, we can consider two YouTubes. Okay, so look at the YouTube that I have explained here. Okay, the first one and the second one. In the first one, both the ends of the tube are equally arranged. Okay, so the water, if you are considering some water inside this tube, the water will not flow outside. Why? Because both the ends are equal, so there is no pressure difference between the two ends of the tube, so water will keep remaining itself inside the tube. But what is the condition of the second tube? In the second tube there will be height difference. One end of the tube is actually little bit upper or higher than the second end. Okay, so which means there is a height difference which gives a pressure difference inside the tube, so that the water will flow from the upper side to the lower side. So in the first tube, there is no pressure difference, so water flow will not happen because there is no pressure difference. But in the second tube there will be height difference which gives a pressure difference. Okay, so water will flow from the upper end to the lower end. This is the case with the conductor. If a conductor we are considering, okay, so this conductor will not have any difference in pressure. As we are talking about electricity, this pressure we say electric pressure. So there are valence electrons present in the conductor, but the problem here is there is no electric pressure difference between the both ends of the conductor. So there is no flow of electrons happening if we are keeping it in a normal way. So how we can bring the electric pressure difference between the conductor? This is happening only when we are connecting the conductor by using a battery. Okay, battery, you already know that there are some kind of chemicals inside. Okay, so these chemicals will undergo some kind of chemical reaction and they will be maintaining an electrical pressure difference between the two terminals. So the positive end and the negative end, okay, so there will be some kind of electrical pressure difference between the two ends. So when you connect this battery to a conductor, to the two ends of a conductor, this battery will give the electrical pressure difference into the conductor, so that the electricity will flow very easily because now the battery is connected. So because of this pressure difference, the electricity flow is maintaining very easily. So this is actually the explanation of electric potential and potential difference. So when a unit positive charge, okay, if you are connect, for example, if you are connecting this battery to the two ends of the conductor, so and we need to bring a unit positive charge, or we need to move a unit positive charge from one end to the another end. Okay, how much work you have to do, how much work or the amount of work doing for moving one unit positive charge from one end of the conductor to the other end. So this we say the potential difference. So potential difference is the amount of work done to move a unit charge from one point to the other point. Okay, but electric potential means that it is actually the same the amount of work done, but here actually we are considering we are moving the unit charge from infinity to one point. So what is the difference between electric potential and potential difference? In both the cases, it is actually the amount of work done. But in electric potential, we are considering that the unit positive charge, we are moving from infinity to one point. But in potential difference, the work done to move a unit charge from one point to the other point. So this is the basic difference between electric potential and potential difference. And in both cases the unit are same, it is volt, and potential difference between 2 points of a conductor can be calculated by taking work done, it is represented by W divided by charge. Charge is represented by Q. So potential difference or electric potential, both are calculating by using the same formula. V is equal to W by Q. W is the work done to move a unit positive charge, okay, and it has to be divided with the charge Q. So potential difference V is equal to W by Q. Now, what is 1 volt? 1 volt is actually when 1 joule of work is done to move a charge of 1 coulomb from one point to the another. Okay, so work done usually we are measuring in by using the unit joule. So work done, the unit of work is joule and the unit of charge is coulomb. So 1 joule divided by 1 coulomb, that will give you 1 volt. So what is 1 volt? 1 volt is the 1 joule of work done to move a 1 coulomb of charge from one point to the another. So 1V is equal to 1 joule per coulomb. Now, the potential difference we can measure by using a voltmeter. And as you know, the voltmeter always connecting in parallel and it has high resistance in just opposite to the ammeter. Ammeter will be connecting in series to the circuit and it will have low resistance. Okay, so the potential difference is measured by voltmeter and it is always connecting in parallel with the circuit. And in the last video we already discussed about what is meant by electric charge, and we already discussed one equation to calculate the electric charge. So electric charge Q is equal to I into T. So this equation we already done in the previous video. For to calculate electric charge we can use one more equation, that is Ne, where N is the number of electrons in the conductor and E is the charge of electron. And charge of electron is constant and its value is 1.6 into 10 to the power of 19 coulombs. So please note two equations from this topic. The first one is V is equal to W by Q. V is the potential difference or electric potential. Both are having same equation for calculation. W by Q, W is the work done and Q is the charge. And electric charge Q is equal to N into E. Or also we can use I into T. Okay, now we can solve some problems. There are some numerical here. So one by one we can solve. The first one is, how much work is done in moving a charge of 3 coulomb across 2 points having a potential difference of 15 volts? In any problem, in examination time or if we are doing the same at home, okay, you need to read the question very well. Read and understand the question and then write the terms given in the question. Okay. So here actually they are asking to calculate the work done. How much work done? So we have to calculate W. How much work is done in moving a charge of 3 coulomb. So charge is given. What is the symbol for charge? That is Q. So Q is equal to 3. Fine. Now across 2 points having a potential difference of 15 volt. So what is V? V is the potential difference, okay, that is 15 volt. So in the question it is given the charge Q, that is 3 coulomb, and the potential difference, that is V, equals 15 volt. So we have to calculate W. So what is the equation for W? We already know the equation for V, potential difference, okay, that is V is equal to W by, what is the equation for V? V is equal to W by Q. Okay, but we need to calculate W. So W equals, therefore W equals you can cross multiply it, V into Q. So V is equal to 15 volt into Q is 3C, 3 Coulomb. So you will get the answer 45. 15 into 3 is 45. It is volt into Coulomb. So the unit of work done is joule, for 45 joules. Okay. Now the second question, how much energy is given to each Coulomb of charge passing through a 6 volt battery? How much energy is given? So usually, if they are asking you to calculate the energy, you should understand that they are actually looking for W. You know, W is actually the energy. Work done we are measuring in terms of energy. So they are asking for you to calculate W, the work done. Okay. So energy you have to calculate to each Coulomb of charge. So what is the meaning of each Coulomb of charge? Each means 1. So 1 Coulomb of charge. So which means Q is equal to 1. 1C. Okay. So how much energy? Energy means work done. Okay. To each Coulomb of charge. So charge given here is 1 Coulomb passing through a 6 volt battery. So the voltage or the potential difference is given. 6 volt means it is the potential difference. So V equals 6 volt. Now W, therefore W is equal to, how do we calculate W? We already derived the equation in the previous problem. V into Q. So V is equal to 6 volt into Q is 1 Coulomb. So we will get 6 joules. Energy we are expressing in terms of joules. So W is equal to 6 joule. Okay. Now the third numerical, if 3 into 10 to the power of minus 3 joules of work is done in moving a particle carrying a charge of 15 into 10 to the power of minus 6 Coulomb from infinity to a point P. What will be the potential at the point P? So what are the things given in the question? If 3 into 10 to the power of minus 3 joules of work, so work is given, so W equals 3 into 10 to the power of minus 3 joules. In moving a particle carrying a charge of 15 into 10 to the power of minus 6 Coulomb. So charge is given, which means Q is given. What is Q? Q is the electric charge. It is given. Its value is 15 into 10 to the power of minus 6 Coulomb. Now, what will be the potential at the point P? So electric potential they are asking for, which means V you need to calculate. So it's a direct question. Therefore, V is equal to, the equation is W by Q. Okay. What is W? W is equal to 3 into 10 to the power of minus 3 joules divided by Q. Q is 15 into 10 to the power of minus 6 Coulomb. Okay. Now, how do we solve this 10 raised to minus 3 and 10 raised to minus 6? You need to move the 10 to the power of minus 6 to the numerator, so that it will become 10 to the power of positive 6. And then you can cut this 3 and 15. So you will get 1 and 5. So it will be 1 by 5 into 10 to the power of minus 3. This 10 to the power of minus 6 we are moving into the numerator. So it will be to the power of positive 6. Okay. Now, what is 10 raised to minus 3 into 10 to the power of 6? which means 10 to the power of 6 minus 3, that is 10 raised to 3. Now 1 by 5 into 10 to the power of 3, which means 10 to the power of 3 means 1000. Okay, 1000 divided by 5. When you cut this one, you will get 2, then 2 zeros, so it will be 200. Okay, so 200 volts. Now the fourth one, how much work is done in moving a charge of 2 Coulomb from a point at 118 volts to a point at 128 volts. So while reading the question, you need to understand the terms that they are giving, and you should write the terms accordingly. So how much work is done? So what we have to calculate? We need to calculate W. Okay, then in moving a charge of 2 Coulomb, so charge is given by Q. We can represent it by using Q, that is 2 Coulomb, and the charge is moving from a point at 118 volts to a point at 128 volts. So what is V? V is the potential difference. Okay, potential difference, they have given two terms, 118 volts to 128 volts. So you need to subtract 128 volt and 118 volt. Okay, so you will get 10 volt. This is the only thing we need to understand from this question. Rest all are same. You can calculate W as usual. We calculated in the previous questions. So W equals V into Q. So V is given 10 volt into Q is 2C, 2 Coulomb. So it will be 20. And what is the unit of W? That is joule, 20 joules. Okay. Now the fifth question, and it is the last question. Calculate the number of electrons in constituting 1 Coulomb of charge. Okay, this is a little bit different question. They are asking you to calculate the number of electrons. Okay, that will be coming in 1 Coulomb of charge. So you already know charge is represented by Q. So Q is equal to how much? It is 1 Coulomb. So what we have to calculate? We need to calculate the number of electrons. So I already gave you the expression for Q. Q is equal to Ne. Okay. Q is the electric charge. Q is equal to N into E. N is the number of electrons and E is the charge of the electron, that is constant value. What is E? Is a constant value, that is 1.6 into 10 to the power of minus 19 Coulomb. Okay. So we need to calculate N. What is N? Ne is equal to Q. So therefore N is equal to Q divided by E. Q is equal to 1 Coulomb. Okay. And E is equal to 1.6 into 10 to the power of minus 19 into unit is C. So basically it is 1 divided by 1.6 into 10 to the power of minus 19. And you can take this 10 to the power of minus 19 into the numerator. So it will become 10 to the power of plus 19 divided by 1.6. Okay. Now 10, better we can solve in this way. I am taking 110 from this 10 to the power of 19. Okay. Then it will become 10 to the power of 18 divided by 1.6. Or another way you can take, like you can multiply both the sides by 10. Okay. So that this decimal point in the 1.6 can be removed. So if I am multiplying 110 here, 10 into 10 to the power of 19 divided by 1.6 into 10, which means it is 16. So 10 by 16 into 10 to the power of 19. When you solve this one, you will get 0.625 into 10 to the power of 19. Okay. And if you take 110 and multiply with the 0.625, the answer becomes 6.25 into 10 to the power of 18. So 1 coulomb of charge will contain 6.25 into 10 to the power of 18 electrons.